This movie we're going to look at derived units. If you haven't watched the movie on the 7 fundamental units, you probably should look at that first. We listed 7 fundamental units that we have in science, and the first 3 were the most important. We had length, and we had mass, and we had time. Those were the first 3. We also had 4 more, and you can watch the video on that. But the units for length in physics, we always put in meters, and mass is always in kilograms, and time is always in seconds. So a lot of times we call this MKS, mass kilogram, or meter kilogram seconds, MKS. And so all other units that we have in science, or in physics especially, are going to be derived from the 7. Primarily, they're going to be derived from these 3. So you'll have other units that are not considered fundamentals, but they are derived instead. So I thought we'd look at several of those. For instance, if we look at volume, the units can be liters, but they also can be things like centimeters cubed or meters cubed. And so you'll see that the volume unit, centimeters cubed or meters cubed, to use a fundamental, meters cubed, is a derived unit. It's derived based on one of the fundamentals. It would be if I had a box and I was trying to figure out the volume, it'd be side times side times side, or maybe a meter times meter times meter for a meter cubed. And so this is a derived unit based on one of the fundamentals, which happens to be the length. Let's look at another one. Let's look at velocity. Velocity is distance over time. Distance over time is the formula. And if you have the formula, you can figure out the units, because the units for a distance in the fundamentals would be meter, and the unit for time in the fundamental would be second. So we have meters per second, which is a derived unit. This is a derived unit for velocity. It's derived from the length, meter, and the time, second, fundamental units. So let's look at acceleration. Acceleration, the formula is change in velocity over time. And the units for velocity, which we just figured out, were meters per second, and then all over time, which is another second. So I have meters per second per second. So this unit is derived again from the fundamentals, meters and seconds. Usually we don't write like that. We write meters per second squared. So this is a derived unit also for acceleration. Let's look at one that's probably pretty easy, density. Density is mass over volume. We kind of remember this because we say we love density. See, mass over the volume. And mass, we know, is in kilograms. And the volume, that's kilograms, that's a fundamental. But the volume is going to be a meter cubed. So I have kilograms per meter cubed. And so this is derived from mass and from length also. So here is another derived unit, which we have for density. Let's try force. Force. The formula for force is mass times acceleration, ma. Another one we could do here is weight equals mass times gravity, but that's really the same formula. Weight, whoops, I forgot T. Weight and force are the same thing. Mass are obviously the same thing. And acceleration, gravity is just one form of acceleration on the Earth. So if we do this, we have mass, which is kilograms, and we have acceleration, which is meters per second squared, we see right there. So we have kilogram meter per second squared. Interesting unit here. And sometimes these units get kind of big and ugly. Like these up here aren't that bad. So we leave them exactly the way they are. But eventually when we get to a unit that looks kind of big and cumbersome, we switch it out with a simple unit. So a kilogram meter per second squared, is what we call 1 Newton. 1 Newton, which is capital N, and Newton. Okay, let's try another one here. Let's do potential energy. Potential energy. The formula for potential energy, these are going to be a whole bunch of formulas we're going to study this year. Potential energy is mass times gravity times height. So what would the derived units be for this? Well, mass is kilograms. Gravity is an acceleration, that's a meter over second squared. And height is another distance, another meter. So we would end up with kg m squared over s squared. So it looks very similar to this one here. This was kgm over s squared. And so now we're going to be multiplying in mass. And that should make sense because look at this part of the potential energy. You see mg. Well, that's what this is right here, mg. So that mg is kgm over s squared. Then we take it times another height or another meter, and we get a kgm squared per s squared. And this is a cumbersome unit too, so we don't write it like that. We call this 1 joule, which is a capital J, 1 joule. All right, let's look at kinetic energy. Kinetic energy is 1/2 mv squared. The 1/2 would have nothing to do with this because there's no unit on it. The mass is a kilogram, and velocity, if you remember, is up here meters per second. So it would be meters per second, but that whole thing would be squared. So what would that be? It would be kg m squared over s squared. And you'll notice that these units are exactly the same. And that should make sense. One's potential energy, one's kinetic energy, but they're just both different forms of the same energy. So they really should have the same unit. So potential energy and kinetic energy are both joules. Okay, so let's do one last one that's kind of tricky. I'll give you a formula. There's a formula for force between any two objects. Any two objects, there exists a force. You might not have known that because it's pretty small for most things. But it's a constant, big G, times the mass of both of the objects, mass 1 times mass 2. And that's all over the distance between those two masses squared. So here's a formula. And we actually know the units for most everything here. So we want to figure out what the derived units are for the constant G. That's what our goal is here. So what we're going to do is we're going to solve this equation for G. So G would equal force times distance squared over m1 times m2. And so if we put in some units here, we know force was in newtons, so we could write newtons. Distance is meters, so that would be meters squared. And mass times mass are both in kilograms, so that would be kilograms squared. Now, the problem with this is that we're not quite done because we want to figure out the derived units in terms of MKS, but we have a Newton in here, which is also a derived unit. So if we're going to plug in what the derived or the MKS derived unit for Newton is kgm per s squared. So I'm going to have a kgm per s squared times meters squared over kilograms squared. And if I do that, you'll notice a kilogram cancels out there, and I'll have a meter on the top. And I will have a meter squared on the top, so that'd be meters cubed. And I have a second squared on the bottom, and I'm going to have a kilogram on the bottom. So I'm going to end up with meters cubed over kilogram seconds squared. A really ugly unit. We don't have anything to replace that, but that is the constant for G. There's clearly a number here. It's a really small number. But here would be the units, meters cubed per kilogram seconds squared. So this is what we're talking about when we're talking about derived units, where we have fundamentals, and in physics we have all the derived units based off of M, K, and S, and we can figure out what they are, even though sometimes we end up putting in another type of a unit. One more, I guess we could just show you while we're here, is called power. Power. And power is energy over time. So energy, you'll see, is joules, or kg m squared over second squared. But this is now all over time for power. So this would all go over time. And that'll put another time on the bottom. So I'll have a kg m squared per seconds cubed. And this, which basically is a joule per second, is another way to write it, but that's a derived unit. So a joule per second is actually called a watt. You've seen this on your light bulbs. Joule per second is a watt, which is a kgm squared over s cubed. So I hope that helps you understand derived units. You should watch the fundamental units first and then come back and revisit this one.